Now we are starting cantilever method of analysis. So this cantilever method of analysis is used for calculating horizontal loads or lateral loads. Okay, this is the problem. So in this problem we have a frame, multi-bay frame, okay, with three story, first story, second story, and third story. So, and we have three bays in the horizontal direction and three bays in vertical direction. So each bay is of the bottom story is of 4 meters and the top stories are of 3 meters and 3 meters respectively. Okay, and the spacing between the bays, that is 5 meters, 4 meters and 4 meters respectively. So for these lateral loads, that is the 50 kilonewtons, 25 kilonewtons and 75 kilonewtons, you are supposed to calculate the moments. Okay, here first we are supposed to calculate the forces which are developed in the frame, that is the vertical forces. Then from those vertical forces we are supposed to calculate the moments. Okay, so by using cantilever method, this method we will see how horizontal forces are converted into the vertical forces. Ultimately we are supposed to find the same thing. Okay, so for this process there are steps which we need to consider. In this cantilever method we will consider the frame with respect to cantilever positions, that is we will consider that the each and every column section is under cantilever condition based on the stories. Okay, so first we will calculate the center of gravity, because in this method the main part of the analysis is center of gravity. Okay, so we need to consider the center of gravity with respect to each and every section. Okay, so how do we calculate the center of gravity of this total frame? Suppose if you want to calculate the center of gravity of a member, that is with respect to this column, one column AEIM, so it is okay, or with respect to a single bay we can consider the center of the frame. But whereas for a multi-bay frame with respect to different story heights and different bay frames distances, so it is difficult to calculate. That is why we go for a process to calculate the center of gravities of the frame. Then after calculating the center of gravity, we have two formulas to find out the vertical forces, that is V1 by A1 by x1 is equals to V2 by A2 by x2 is equals to V3 by A3 by x3 is equals to V4 by A4 by x4, and one more formula, that is P into h by 2 minus V2 into L1 minus V3 into L1 plus L2 plus V3 into L1 plus L2 plus L3 equals to 0. From this we are supposed to calculate the vertical forces V1, V2 and V3. Okay, so first we will go for the step of analysis, considering that the top section ABC. So we will only consider the first top section of the story. So in this method, considering that center of gravity lies at the center of this band. So individually we need to consider the center of gravity. First we will consider that x1 is the distance of center of gravity to the column A. Okay, and next x2 is the distance from center of gravity to B of column, and x3 is the distance from center of gravity to CG column. Okay, and x4 is the distance of center of gravity from BH column. So to calculate the values of x1 and x2, we use a common method. Okay, that is x1 is equals to, first we will consider that the center of gravity lies with respect to the first column, that is at the position of first column, that is A. Okay, so by using that formula we will take it as, if x1 is the center of gravity, then we will take it as the formula 5 into A. That is, the column BF is at a distance of 5 meters from AE column. Okay, and next 9A, that is, the column CG is at a distance of 9 meters from column AE, and next DH, the column which is at a distance of 13 meters from AE. So the area of cross section of each column is A, so that is 5 into A plus 9 into A plus 13 into A by area of each column, that is A plus A plus A. Totally we have 4 columns, that is why we will take it as 4 columns. So from this we will find the value of x1. Okay, next x1 is equals to 27A by 4A, that is x1 is equal to 6.75 meters. Similarly for x2 it is, so as we go for x2, x2 is nothing but the distance from CG to BF line. So in this process we will consider that the center of gravity lies with respect to the column BF to find the value of x2. So for that we will take the value of x2 as minus 5 into A. 5 as we are considering minus 5 because A is to the left hand side of BF, that is why we will take the negative values. Okay, whatever the distance it may be, either the result whatever we get positive or negative, that may not be big into issue. Okay, so the column distance from BF to AE is minus 5A, and CG is 4A, and DH is 9A. So totally we will take it as minus 5A plus 4A plus 8A by 4A, that is equals to 1.75 meters. Similarly for x3, that is center of gravity lies at CG column, third column. So that is equals to minus 4A is the distance of BF column from CG, and 9A, minus 9A is the distance from AE to CG, and 4A is the distance of DH to CG. Okay, so from this we will get x3 as 2.25, and x4 is equals to minus 4A, that is CG is at a distance of 4A, and next BF is at a distance of 8A, and AE is at a distance of 13A. So totally minus 4A minus 8A minus 13A by 4A, that is equals to 6.25 meters. So we have got the x1 x2 values. Why we are finding these x1 x2 values is, here if you want to calculate the vertical forces developed in the member, so we require this. Okay, so the x1 x2 and x3 and x4 values we will be substituting in this equation, and then ultimately we will find the values of V. So to find the values of V1, V2, V3 and V4, we will use this. As the columns are all of same cross sectional area, there is no change in the cross sectional areas, so area of all the columns will be same. So that is why V1 by A into x1 is equals to V2 by A into x2 is equals to V3 by A into x3 is equals to V4 by A into x4. Next, as A's are common, we will neglect those A's, that is V1 by x1 is equals to V2 by x2 is equals to V3 by x3 is equal to V4 by x4. From this simplified process, after substituting the values of x1 and x2, x3 and x4, next we will take any two of the values and take the common value factor as V1 for all the sections. Okay, take V1 as the common factor, equating V1 by 6.75 is equals to V2 by 1.75. So we will get V2 in terms of V1, that is 0.25 of V1. Similarly for V3 it is 0.33 times of V1, and V4 it is 0.92 times of V1. That is, we are equating V1 by 6.75 is equals to V2 by 1.75 and V3 by 2.25 and V4 by 6.2. Okay, so coming to the third story, that is P1 into, as we have seen just previously the formula, that is P1 into H1 by 2 minus V2 into L1 plus minus of V2 into L1 plus V3 into L1 plus L2 plus V4 into L1 plus L2 plus L3 is equals to 0. So P1 is the load which is acting at the top story, that is third story, into height of the column is 3 by 2 minus 0.25 into V1. We are substituting V1 value is 0.25, V2 as in terms of V1 and V3 in terms of V1 and V4 in terms of V1. So L1 is 5 meters, L1 plus L2 is 5 plus 4 meters, L1 plus L2 plus L3 is 5 plus 4 plus 4 into V1. So equation will be getting all in terms of V1. So first we will find the value of V1, that is 2.23 kilonewtons. After that we substitute the value of V1 in V2, V3 and V4. Then we will get the values of V2, V3 and V4, that is from these values. Okay. Next, after that similarly we will go for second story. So in the second story, the P1 value, that is the load which is acting horizontally, will be changed, because the third story load will be added to the second story, that is top story will be added to the below story. So load will be 25 plus 50 into 3 by 2. Height of the story is 3 by 2. So the values is similar as previous one, that is 16.81 into V1 is equal to 0. So it is then from this, in the second story the vertical forces are 6.69 and vertical V2 is equals to 1.67, V3 is 2.20, V4 is 6.15. Okay. Similarly for the first story we will be analyzing, that is load will be added 25 plus 50 plus 75 into 4 by 2 is equals to 16.81 into V1. This will not be changed, only V1 is equals to 300 by 16.81, that is equals to 17.84. From this V2 is 4.46, V3 is 5.89, V4 is 16.41. Okay. These vertical forces values we will be imparting in the frame over here. Okay. Okay, so in the first top story values are 2.23, 0.55, 0.73 and 2.44. Okay, so for this 2.23 is with respect to first section, and next 0.55, 0.55 and 0.7.